In this video, I'm just going to go through a few of the especially tough examples in the study guide so that I can prepare you for the test. Now, this video is going to focus on using the distributive property to simplify rational expressions and on factoring using the greatest common factor. So this example right here was number 4 in the study guide. Now, in order to simplify this, we need to use our distributive property. There are 2 ways to do it. You can make all the negative exponents into positive ones first if you want to, but I'm just going to start by straight distributing. So that means that I need to take this term on the outside of the parentheses and multiply it by each term inside the parentheses. So I'm going to multiply the outside by the first inside term. That's going to give me m to the negative 4th over n squared times 5m to the 3rd over n cubed. Then I've got a minus sign right here, so I'm going to subtract. And then I've got to take this outside term times the second term. So I've got m to the negative 4th over n squared times n to the 6th p to the negative 3rd over m to the 3rd. Now that I've done my distributing, I'm going to simplify each term separately. So I'm going to simplify the first term and then simplify the second term, and then I'm going to sort of combine. Okay, so on this first term, I want to start with my numbers. So my only number or coefficient in this term is 5, so I'm going to write that first. Now here I'm multiplying m to the negative 4th times m to the 3rd, and I know that I'm multiplying because they're on the same side of the fraction bar. They're both on top. So I've got to add my exponents. That would be m to the negative 4 plus 3. And then here on the bottom of the fraction bar, I've got n squared times n to the 3rd. Since these are both in the denominator and I'm going to multiply them, they're going to stay in the denominator. So that's n to the 2 plus 3. I'm multiplying them, so I'm adding their exponents. Now for my next term, I don't have any coefficients here, so I don't have to write those first. I've got m to the negative 4th that I can combine with m to the 3rd in the denominator. Now, since one is on top and one is on bottom, I have to subtract their exponents. And when I subtract the exponents, the variable moves to the top, or to the numerator. So I have m to the negative 4 minus 3, because the 3 is on the bottom, so I have to subtract it. Okay, so that takes care of my m's. Now my n's, I have the n to the 6th divided by n to the 2nd. So since they're on opposite sides of that fraction bar, I'm going to have to subtract their exponents. So I have n to the 6th minus 2. And again, because I'm subtracting the exponents, everything moves to the top. And then I have p to the negative 3rd. All right, so I've combined all my like bases. Now my next step would be to simplify those exponents. So this would give me 5, and then I've got an m. Negative 4 plus 3 is negative 1. And then in my denominator, I've got n to the 2 plus 3, which is n to the 5th. In my second term, I've got m to the negative 4 minus 3, which is negative 7. And I've got n to the 6 minus 2, which is a positive 4. And then I have p to the negative 3rd. Now to finish simplifying this problem, the only thing I have left to do is to make all my negative exponents positive by moving them to the opposite side of the fraction bar. So my 5 has a positive exponent of 1, so it's going to stay in the numerator. My m has an exponent of negative 1, so I have to move it into the denominator and make its exponent a positive 1. And my n is in the denominator and has a positive exponent, so it's going to stay in the denominator. Then I am subtracting. Now my m to the negative 7th, since it has a negative exponent, it needs to move into the denominator, and its exponent becomes positive. My n, it has a positive power in the numerator, so it's going to stay in the numerator. And my p has a negative power in the numerator, so it needs to move to the denominator, and its power becomes positive. Now, this is the simplified form of the original problem. Now let's do another one of those. This one is number 10 in your study guide. Sorry guys, having some focusing issues here. All right, looks like that's as good as we're going to get, but you guys can look at problem number 10 in your study guide. Now it's the same thing. I'm having to distribute my outside term to each term inside my parentheses. So I have to multiply this outside times the first inside term. Now that gives me a to the negative 2 over b times ab over c to the negative 4th. Then I've got a plus, and I have to multiply this outside term by the second term in parentheses. So a to the negative 2 over b times cb to the 6th power over a to the negative 3rd. So I've done my first step, which is distributing. Now my next step is going to be to combine my like bases. So in this first term, I have a to the negative 2nd times a to the 1st. They're on the same side of the fraction bar, so I'm going to add their exponents. So a to the negative 2 plus 1. I have b divided by b, or b to the 1st divided by b to the 1st. So since they're exactly the same, b divided by b is just 1, and my b's are going to cancel out. Then in the denominator, I've got c to the negative 4th, and that's not going to combine with anything because it's the only c in that term. Plus, and then in my second term, I have a to the negative 2nd divided by a to the negative 3rd. So since they're on opposite sides of the fraction bar, I'm going to subtract my exponents and bring them to the top. So I have a to the negative 2 minus negative 3. Don't forget that I am subtracting a negative, so I do need both of those negative signs there. Then for my b's, I've got b to the 6th divided by b to the 1st, so I'm going to bring it to the top and subtract their exponents, 6 minus 1. And then I also have c to the positive 1st. Now I'm going to simplify my exponents. So I've got a to the negative 2 plus 1, which is negative 1, over c to the negative 4, plus a to the negative 2 minus negative 3. Now remember that minus the negative is really plus. So negative 2 plus 3 is 1. So that would be a to the 1st. I've got b to the 6 minus 1, which is 5. And then I've got c. Finally, I'll make all my negative exponents into positive exponents. So in my first term, a to the negative 1st is in the numerator. It needs to move into the denominator, so my exponent will become positive. And c to the negative 4th is in the denominator and it's negative, so it needs to move to the numerator and become positive. And then in my second term, none of the exponents are negative, so they can all just stay right where they are, and that is my simplified solution. Okay, so those are the distributing to simplify rational expressions. Now we're going to move on to factoring. This one was number 14, and it said that number 14 needed to be factored completely. Now, in order to factor this completely, we're going to have the greatest common factor and what we would multiply the greatest common factor by to get our original expression. The way we do that is to factor out each expression first. So if I'm going to factor 15, it's 3 and 5. So to rewrite negative 15, I would write negative 3 times 5, and then I have c, and then I have d to the 4th, so that's 4 d's. All right, now I'm subtracting the 20, and if I'm going to factor my 20, I've got 2 and 10 is 2 and 5. So that would be 2 times 2 times 5, c to the third, so 3 c's, and then d squared, so 2 d's. Now I circle what they have in common to find my greatest common factor. So it looks like they've got a 5 in common, they've got a c in common, and then they have 2 d's in common. So my greatest common factor is 5 times c times d, which is 5d squared c, or you could write cd squared. Now what's left over is written inside the parentheses. So I've got -3 times d, which is a -3d squared. Then I've got minus 2 times c times c. Now 2 times 2 is 4, and c times c is c squared. And now I have factored this out completely. Now another thing that I could have done here is to pull out a negative, because notice that my first term is negative, my second term is being subtracted, so I could have pulled out a -5d squared c. And if I had done that, factored out the negative out of each term, that would have made my terms inside into positive ones, so 3d squared plus 4c squared. Now, either of these answers are acceptable, so if you don't think to factor out the negative, that's okay, but it's also possible. And finally, here we've got number 18 on your study guide. Now, number 18 on the study guide just wanted us to find the common factor. So we're going to factor each term individually, and then those things that they have in common are all we need for our answer. So we've got 5 is the factor of 5, p squared is p times p, q to the 5th is 5 q's, and r squared is 2 r's. Then it's minus. 10 is 5 times 2. Then we have p, and then we have q squared, so that's 2 q's. And then we have r squared, so that's 2 r's. Now, since we're looking for the greatest common factor, we just find what they have in common. So they've got a 5 right there. They have a p right there. They've got 2 q's. And they've got 2 r's. So our greatest common factor here is the product of what they have in common. So 5, p, q times q, which is q squared, and r times r, which is r squared. And this is our greatest common factor.